Hi, this is Jose Luis and welcome to this new hands-on exercise that I am recording for the series Introduction to Parametric Modeling. In this one, I'm going to teach you how to model a free-form pavilion, okay, which is going to be driven by two curves that are in Rhino and that we can move and we can modify just with the control points, etc., etc. But at the same time, there's going to be some parameters like, for example, how slanted the Pavillion is going to be to one side or the other, or how high the central points of this pavilion canopy are going to be from the center. Okay, this is going to be a super simple exercise, but I'm actually using this exercise as a vehicle to explain simple data tree manipulation and two of the main operations that are important in this category, which are flattening data trees and grafting data trees. This exercise is going to be a continuation of a video that I recorded previously, so I won't start from scratch. I will start from like halfway through it, but I will explain anyway what the basics of the exercise are, and but you're welcome to check the previous video if you want to learn a little bit more. Okay. All right, freeform pavilion, data tree manipulation. Let's take a look at what the problem is and how can we solve it. So starting off where we left it in the previous video, I have the two curves that I'm bringing in from Rhino, and then I'm subdividing each one of them into a family of points. I am joining each one of those families of points with straight lines, and then I'm evaluating each one of those lines at a relative parameter across the domain from 0 to 1 in this case, because they're straight lines. And then I'm decomposing the XYZ coordinates. To the Z coordinate, I'm adding a fixed distance, like a height, and then I am reconstructing those points at a distance above that level. And then what I'm doing is I am trying to create an interpolated curve that goes between the first family of points, then the second family of points that I have created, the ones on the top, and then the third family that I have created, which is the ones on the right-hand side. And the problem that I was getting, if I turn everything else off, the problem that I was getting is that as soon as I did that, when I plugged in my three families of points, what I was getting was one single curve that was interpolating through all the points sequentially, one after the other. Okay? And I was not really sure about what the problem was or how to fix that. So now that we know what data structures are and how to manipulate them, we can take a closer look at what's happening here. So the first thing that I'm going to recommend, always, when you have a problem that you suspect might be related to data, then the first thing you probably want to do is to take a look at the data using a panel. So what I'm going to do is I'm going to use this panel and I'm going to plug it into this list of points, the first list of points. And I can see that from a data tree perspective, what I have here is a data tree that has one branch that is called 0, 0, and then it has 15 elements. And this, for the sake of clarity, I'm just going to reduce this to a lower number, like for example, I don't know, 5, something smaller, so that I can see here that I have now 6 points. All right, so that is my first family. And then what I'm going to do also for clarity is that I'm going to copy paste this panel 3 times, and I'm going to compare the first family with the second family and with the third collection of points. What you can see is that from a data tree standpoint, something that is very interesting is that the 3 of them have a very similar structure. The 3 of them are trees that have one branch. The branch has the exact same name, and all of them have the exact same amount of items inside of the list. So that is already giving me an indication of what's going on, okay? But just for the sake of making sure that I understand what's going on, what I'm also going to do is that I'm going to try to mimic, because you see that I'm taking the 3 collect lists and then I'm plugging them into the same input. So what I can't really see is what the data looks as it is going into this component. So what I'm going to do to make sure that I have a better look at that is I'm going to move this here, and then I'm going to drop here a panel, a large one, And I'm going to try to replicate what's happening here at the input. So what I'm going to do is I am going to plug in the first list here, and I'm going to expand this a little bit. Then I'm going to plug in the second one, pressing the shift so that I make sure that I add it together. And you see what has just happened there? Wow, that was interesting. And then I'm going to add the third one, which also gets added right there. That is super interesting because take a look at what's happening here. As soon as I combine the three data trees into the same input, what happens is that I stop having three different branches with the name 000. I don't have those three branches anymore here. Now what I do have is one single data tree where all the elements are in the same branch. And actually, the index numbers, if you notice, they have also changed. Numbers that were from 0 to 5 are now from 0 to 17. So that has been quite a radical change. Why did this happen? Well, it happened because of one of the reasons that I explained before when I was talking about data trees, which is the fact that branch names are unique. So paths are unique, and a data tree cannot have several branches with the same ID. What happens when I combine data inside of the same data tree that had originally data on the same path names? What happens is that Grasshopper takes all the data that was in the same branch and it combines them together into the same branch. So everything that was 0 in the previous data trees now gets combined and consolidated into the same branch, and the index numbers rearrange so that they are sequential one after the other. So this is a default behavior from Grasshopper, and what means is that the data that is going into the interpolate component looks something like this. All right. So, that's one thing that is important to note. Now, the other thing that we need to keep in mind, and is super important, is that, as I explained in the previous video when I was talking about data tree operations, most components work at the level of lists. And the operations that they do when they take a bunch of data, they do them individually for each one of the lists that is contained of the data tree. What that means is that because the data tree that is coming into this component is one that has this 18 points on the same lists, that is the reason why this component is trying to create one single curve that is going through all the points one after the other. And that is why we are not getting the result that we wanted, which was to have a collection of curves that is going from the first point to the first point to the first point, and then another one from the second point to the second point to the second point, etc., etc. We're not getting that because the structure of the data is not in a way that will generate those different curves. The structure of the data is in a way that the component will only generate one single curve throughout all of these components, throughout all of those points. So what is the solution then? The solution then is that we need to somehow restructure all this data here so that whenever we plug it into the vertices input of the interpolate curve, the data somehow is grouped in one branch for the first point here, the first point here, and the first point here, so that we create one curve through those 3 points. Then we need a second branch that has the second point here, the second point here, and the second point here, so that we create one single curve throughout that list. Another branch with a list that contains the third point, the third point, the third point, the fourth, the fourth, the fourth, so we create individual curves with lists of 3 points. All right? So, if that's the case, what do you think we would do in this case? Would we take these data trees here and would we flatten them or would we graph them? Give it some thought. Give it 1 minute. Pause the video if you need to. All right. So, let's take a look at the options. If we flatten the data, then if we flatten these data trees here, then what we're going to get is actually something that is going to be super similar. It's going to end up being 3 lists with one single list, and then the branch, instead of being 0, 0, is going to be called 0. But we're going to be in the pretty much the same place, because as we combine them, we're going to end up with one branch that is called branch 0, and with all the elements one after the other. However, if we take into consideration, if we think that whenever branch names are the same and we combine data trees that have the same branch names, all the items will go into that branch, then something that we might do is we may want to take a look at grafting each one of these data trees so that we generate one branch per item. So let's take a look at what that could look like. I'm going to graph this tree. So I'm going to graph this one, and I'm going to graph this one, and I'm going to graph this one, and I'm going to plug those in here, and in here. What happens now is that you can see that each item has its own branch that has different names, correct? And then by having different names, what's going to be happening now is that as soon as I combine these new data trees that have so many branches, as soon as I combine them in the same data tree, look at what's going to happen. We have 7 branches here. Now, as I add the second one, pressing Shift, the 2 branches that are 0, 0 combine into one list. The 2 branches that are 0, 0, 1 combine into one list. The 2 branches that are 0, 0, 2 combine into one list. And if I add the third one, pressing Shift, the same thing happens. The 3 branches that are 0, 0, 0, they combine into one list. The 3 branches combine into one list, and the 3. And very nicely now, we have we have the first point combined into one single branch, the second combined into one branch, the third, and we have all the elements on the data tree combined by first, second, third elements of each one of their original individual data trees. As soon as I give this data structure to the interpolate component, look what's going to happen. One single curve is created for each one of the lists or each one of the branches. Again, because most Grasshopper components work at the level of lists. All right? So they operate with all the elements that are contained on the same list. Very rarely they combine elements from different lists or from different branches. It's not how Grasshopper works in this case. All right? Yoo-hoo! So this was a pretty good example of why grafting, for example, can be useful. And it can be useful to do what's called data matching, or in a way, taking data that was in different places and recombining it in a way that is ordered and it matches a particular order. Okay? Wonderful. Sorry, I did a terrible thing. I combined. So let me do this. You typically don't want to go through a panel before plugging things into a component, because whenever you go through a panel, things get turned into text, and only certain things can be reconstructed from text into actual geometry. So let me take that back and plug in the first one, then plug in the second one with the Shift, and plug in the third one with the Shift. All right. Okay, takeaways. Grafting can be really useful to group things together smartly, especially when you have components that need to operate at the level of lists. Okay? And as usual, please use panels to make sure that what you are doing is that you have a really good sense of what you are doing. The other thing that I would like to do now is just to wrap this up. Remember that this was for some kind of competition visualization. So I have the arches that make the structure of my freeform pavilion, but I kind of want to have something solid. This is not really solid, but something that I can do a rendering with and that I can put some textures on. So I would probably want to create a lofted surface throughout all these arches. So let's go back here, and then it's going to be just as simple as doing freeform, loft, and then place using a loft component across all these curves, except for that this is not working. Whoa, where is my loft? What is happening here? All right, what is going on? Whoa, well, first thing that I need to do whenever something is not going well, let me take a look at what we have. What is going on? I have a data tree with 6 branches, all of them being empty. Oh, that is very strange. Can I place another panel to take a look at what the data that is going into the loft looks like? So the data that is going into the loft component looks something like this. It's a data tree that has 6 branches, and each one of the branches has each one of the curves that corresponded to the data tree that I added before. So I had a tree with lists of points, and now I have the same data tree with one curve for each one of those planes, for each one of those points, for each one of those point collections. So this to me makes sense. But why, whenever I plug this into the loft, I am getting 6 empty nothings, nulls, and I'm not getting the surface that I want? Well, let's think about this again. If you remember, what have I said? 95% of Grasshopper components, they work at the level of a list. They try to operate with all the elements that are on the same list, but they do not combine elements that are on different lists. So now, with that perspective, let's take a look at what's happening here. You see how this data tree is actually a data tree with 6 branches, so 6 lists that contain one single element each. So what the loft component is trying to do is, for each one of these lists, is trying to loft a surface through one single individual curve. What it's not doing is what we intended to, which is to loft a surface through the 6 curves. And it's not doing that because the 6 curves are on different lists. And therefore, it's trying to create 6 surfaces with one curve each. Therefore, that is not a possible solution. And then I get these null results here. Okay? So the data structure that is going into the loft component is not working well for me. I need to change this somehow. The way I need to change this is I need to somehow make sure that all these curves are on the same list so that I can generate one surface through the 6 curves. And what data tree operation have we seen that removes all the branch complexity, whatever, and leaves all the elements one after the other on the same list? You don't even need to think about this, right? That's going to be flattening a tree. So if I go here and I go to tree and I go to flatten tree, I'm going to try this out. So let me move this a little bit farther away. So I'm going to flatten this tree, and I'm going to, with a panel, make sure that I'm getting what I want. And what I have now is that all my branches are gone and all my curves are on the same data list. And if I plug this in here, now you can see that what I get is the result that I intended, which is one single surface that gets lofted through all the elements on the one single list. All right? And of course, this is parametric, so I can move things around and things will adapt, etc., etc. And I can move this, etc., and all those things. All right. And all right. So that was a free-form pavilion, and that was an exercise where what this exercise was all about was exploring data tree manipulation and why certain times we need to graph data, and why some other times we need to flatten it so that we can keep all the data on the same list and operate. All of this again under the perspective that most Grasshopper components will always work with data that is on the same list, not across different lists on the same data tree. One last word is that I would like you now to see how in my Grasshopper definition, which got a little complex, I have like a bunch of different types of wires, actually. I have wires that are a single solid line, I have wires that are a double solid line, and I have other wires that are a kind of dashed sort of double line as well. The only difference between those is that what Grasshopper is telling you is that what the data that is going through for single solid lines is just one single item. So anything that is a single solid line is just going to be one item. Whereas when it's a double solid line, what it means is that it's a data tree that has only one list. So no matter what it is, it's just one single list of data. But as soon as we have the dashed line, what we are seeing is that inside of it, we have a data tree that has multiple branches. So the difference between these three qualities is whether if it's single element, single list, or multiple lists. All right, that's the only thing. Wonderful. So this was Freeform Pavillion just as a vehicle to exploring simple data tree manipulation. All right. I hope this was useful. And again, trust me on this one. 90% of the problems you're going to have are going to be related to data, and then grafting and flattening are going to be super, super helpful always as a first try to see if you can fix those problems. And remember, panels are your best friends here. So always, whenever you suspect something might be going on with the data, plug in a panel and the input, plug in a panel and the output, plug a panel, do this exercise of recreating what multiple inputs into the simple panel, what they look like and what data structure they generate, so that you can see and mimic what is happening at the input of your component. It's a really, really useful and helpful operation. All right, wonderful. If you thought this was useful, and if you thought you're liking the work that we do in this channel, maybe you want to consider liking this video, subscribing to the channel, turning on notifications, leaving a gratitude message in the comment, whatever you think is whatever you think we're worth. All right, thank you very much, and see you on the next video of this series, Introduction to Parametric Modeling.